Okay. Quiz 3. Question 1 asks you, what is the mass of 2.5 mole calcium carbonate? Ask you mass. I used to be right in that corner many times. So mass, moles, and the number of moleculars part is this. So mass, lowercase m is mass divided by molar mass mw. You can find the moles. Then from moles back to mass is mole multiplied by molar mass. From moles to number of particles, and these particles could be atoms, could be moleculars. Depends on the substance. Because some substance exists in the format of atoms, like a metal. Some substance exists in the format of moleculars, like a water. Okay. So this particle could be atoms, could be moleculars. So for more to number of particles, you need to multiply by Avogadro number. So Avogadro number 6.022 times 10 to the 23rd power more. If we know the number of particles, how can we get back to more? Number divided by Avogadro number. Okay. So again, this chart is very important. Everybody must understand. Otherwise, you cannot pass any chemistry test in the future. Always have this. Tell you more. How can you find how many gram, which is mass, right? So more multiplied by molar mass. How can you find the molar mass? You need to use periodic table. Okay, use periodic table. This periodic table tells us calcium 40.08. Calcium carbonate is CaCO3. So calcium 40.08. C is 4.01. O is 16. 3 O, so 16 times 3. Okay. Add these together. Add all these together. 100.08. So 2.5 times 100.08 gram per mole. It's clearly around 250. So 250.2 gram. So you should choose B. Can you understand this? Okay. Question 2 asks you how many molecules of water in 2.5 moles, 2.56 moles So this time tell you moles. Ask you how many molecules. Right? So more multiplied by Avogadro number. Right? 2.56 more multiplied by this Avogadro number. So use your calculator, only put this regular number in your calculator. Don't put this exponent there. Sometimes if you put this exponent number in your calculator, may give you trouble. Okay. So if you put this 2 in the name calculator, will give you 15.4. Okay. Then exponent is still there. Since this is more larger than 10, right? We can move one decimal place because the scientific notation is a number between 1 and 10. If larger than 10, we may move one decimal place back, 1.54. Move one decimal place back, you need to multiply by 10. 10 is 10 to the 1. Together with 10 to the 23rd, the total 24. Okay. So clearly, you choose answer C. Okay. If you are very smart, you see this 4 choice, you even don't need to calculate. Because only C is an extreme large number. Whenever ask you how many moleculars or how many atoms, the answer always a very large number. And here I gave 3 choice. A is 18, B 2.5, 6, and D is 46.1. Only C is an extremely large number. Of course, C. You even don't need to calculate. You get it? Again, in the future, if ask you how many moleculars or how many atoms, the answer always a very big number. If only one choice is a very big number, that is the answer. Of course, if more than one choice with very big number, you do need to calculate the moles multiplied by Avogadro number. And Avogadro number I provide you here. During any test, always provide you number. Always provide you Avogadro number. You're okay with this? Okay. 3. Question 3 asks you how many moles of copper atoms are there in 2.58 gram? 2.85 gram copper. Ask you how many moles? What this is? This is mass, right? 2.85 gram. Here you mass. Ask you moles, right? Here you mass 2.85 gram. Ask you how many moles? Here you mass. Ask you moles. Mass divided by molar mass. Then what is the molar mass for copper? Take a look at the periodic table, right? I provided you periodic table. So copper molar mass is 63.5. So 2.85 gram copper divided by molar mass is 63.5. One more, right? So mass divided by molar mass. Yeah, the table tell you 63.5 copper. So use calculator 2.85 divided by 63.5. You can easily get is 0.0448. 3 significant figure. Your answer can only have 3 significant figure, right? So your choice is D. Here, okay, again, we use this charge. Then question 4. Asking how many atoms of Fe is iron are there in 23.5 gram? 23.5 gram iron. How many atoms? Right, so this time tell you mass. Ask you how many atoms of iron. Tell you mass. Ask you how many atoms of iron. This is atoms, number of atoms. So this time you need two steps. From mass to mole first, then from mole to number of atoms. So from mass to moles, there's mass divided by molar mass. What is the molar mass for iron? Take a look at the periodic table. 55.85, right? 55.8 is fine. Okay. Then you need to multiply by Avogadro number. Actually, we don't need this. So multiply by Avogadro number. 6.022 times 10 to the 23rd power atoms per mole. Gram cancel this gram, mole cancel this mole, leftover number of atoms. So use your calculator, 23.5 divided by 55.85, multiply by 6.022. Okay, again, don't put this exponent in the calculator. Okay, makes things easier. Okay, so this will give you a number will be 25. No, this is a 0.5, less than 0.5. Then less than 3, so 2.53. Yeah, 2.53 and to the 23rd. So clearly, this answer should be D. So again, this time, if you're really smart, you don't need to calculate, because only one choice is extreme large number. So whenever ask you how many molecules or how many atoms, the answer should be a very big number. Okay, and if only one choice is a very big number, that is the answer. Of course, if I give you more than one choice with very big number, you do need to calculate. Okay. This time again, only one extremely large number. Then that is the good answer. Hey, so there's two steps: from mass to moles, then from moles to number of atoms. Are you okay for this question 4? If you're okay, then we go to next. Question 5. Ask the percentage of iron in compound Fe2O3. How can we calculate the percentage of iron in Fe2O3? So we need to use periodic table. So Fe in Fe2O3, you need to use periodic table. So Fe, what is the molar mass? Periodic table tells us 55.85, right? Then denominator, you have 2 Fe, 3 oxygen. Your table tells us oxygen is 15.9994, then just 16 times 100%. So use your calculator. This should be 69.94. It's not 67, 66.67. No. Hey. Choice A. Some of you pick this choice. This choice comes from 2/3 here. Cannot be so easy. 2/3? No. We have copper students like this. No. This is not chemistry. So actual value is 69.94. So you should choose B. The multiple choice, you need to work on it, not just guess. Of course, if you really don't know how to do it, just close your eye, make choice. Most case, you will make a wrong choice if you close your eye. So I gave you 4. You have only 25% chance to select the correct choice. You need to know reasonably why this is correct. Are you okay? Then question 6. Empirical formula of a compound is CH2. And the molar mass of this compound is 84. Ask you what is the molecular formula? So again, what is the difference between empirical formula and molecular formula? For definition, everybody know, right? Empirical formula is the symbol is the whole number ratio. Atoms from each element, right? So this is carbon is 1, hydrogen is 2. This is symbol is whole number ratio, 1 to 2. Molecular formula. Here are exact number of atoms from each element, right? This is definition. Everybody know. And what this exactly tell us? What is the difference or their relationship? Is just the whole number. Right? This whole number could be 1. If this is a 1, this means empirical formula, molecular formula exactly the same. Could be 2, could be 3 or 4 or 5 or 6 even, or 7, 8, 9, or possible. Because this is exact number of atoms from each element. And this is simple is the whole number ratio. Then from molecular formula to empirical formula is everybody divided by the whole number, the maximum whole number or common factor, right? So our job is to find that number. Okay? How to find that number? We have another condition. We have not used it. Molar mass of this molecule is 84 gram per mole. To figure out that number, since this is a molar mass, of course, we need to figure out molar mass of the empirical formula, right? So we can compare this to molar mass. Okay, what is the molar mass for this empirical formula? Use periodic table again. So one carbon is 12. Two hydrogen, each hydrogen is 1. So total 14. Right? So molar mass for empirical formula are 14, while molar mass for the molecular formula is 84. Then their ratio clearly is 6. Right? Then what is the molecular formula? So molecular formula from empirical formula and what they multiply by 6 back to molecular formula, right? So C6H12. You get it? Because molecular formula C6H12 and what it divided by 6, you back to CH2. This is the way normally we'll find out the empirical formula, right? So your molecular formula will be C6H12. Your choice is B. Okay. Are you okay with this? Okay. Number 7, balance equation. These two relatively easier. This reacting acid and a base, right? OH is the base. NaOH, I will say this is the most famous base. This hydrogen is acid, right? For acid base reaction, balance equation, critical thing is one hydrogen ion react with one hydroxide ion, produce one water. Okay. Since here we already have two hydrogen ions, then definitely we need two hydroxide ion and produce two water. So one hydrogen ion react with one hydroxide ion, produce one water. This is a critical thing for any acid that react with base. Sorry, this is a mistake. Why this is wrong? Negative, yeah. OH is negative, hydrogen is positive. Okay, so this is critical thing for any acid-base reaction. So one hydrogen ion react with one hydroxide ion produce one water. If we have two hydrogen ions there, H2 is two hydrogen ions, then you must have two hydroxide ions. That's why I need to put the 2 in front. This means two hydroxide ions. Then produce two water. Then balance the rest. Two sodium, yes, we have two sodium. One SO4, one SO4. It's balanced. B. CO react with O2, produce CO2. Then this is normal procedure, the balance equation, right? We select those elements show up one time in both sides because that is easier. Oxygen show up 2 times the left side. So don't select the oxygen first. Select the carbon 1 time, but not here, right? Right side only 1, of course 1 time. So balance carbon first. And carbon already balanced. then we have to work on oxygen. To work on oxygen, the trick is this is one oxygen, this is two oxygen, the odd number, right? Right side O2, whatever number you change in front. Again, balance equation, the rule is you can only change the number in front. You cannot change this subscript number, right? Let's see, this A, I didn't change this, I didn't change this. We cannot change it. If you change this subscript number, substance changed. As you balance equation, you only change the quantity. You cannot change the substance. The quantity is the number in front of each formula. So whatever in front of this could be, okay, whatever in front of this, oxygen always even number because already two have two oxygen there, right? But this depends on the number in front of it. If odd number, this is odd. If even number, this is even. So to balance oxygen in both sides, you need to think about make this odd number become even because the right side, this oxygen always even because of the two there, right? So make this even, of course, try two first. Of course, you can try four. To balance the equations, smallest set of data. Okay. Some of you, again, some of you mark this as 4 NaOH plus 2 H2O4 and 4 water to this. This is fine, but this is not the actual balance equation. Actual balance equation are the smallest set of numbers. So this is the smallest set. Okay. So again, this try even number smallest 2. 2 carbon, then you have to. Right? Carbon must balance. This also becomes 2. The 2 carbons they're balanced. Now take a look if oxygen balanced. Right side 2 times 2 is 4. Left side 2 times 1 2 plus 2 4. It's balanced. Are you okay for this? And then most problem comes from question 8. Many of you got lost. The balance of the equation is 2Al reacted with 1 Cr2O3 produce Al2O3 and 2 Cr. And 55 gram Cr2O3 mixed with 16 gram Al. Ask you which one is the limiting region, either this or this. Right? Ask you which one is the limiting region. The strategy is you can pick any one of these to calculate how much is the other one needed. So if you pick this, 55 gram of Cr2 react, we can figure out how much Al needed, then compare with 16 gram. Then we can judge which one is the limiting region. Of course, you can also pick 16 gram Al react, then find out how much Cr2O3 needed, then compare with 55 gram. Your answer will be same. So the idea is if 55 grams Cr2O3 all reacted, we can find how much Al needed. So since 55 gram is a mass, so we definitely need to convert it to moles. mass always convert to more. So mass divided by molar mass, right? That chart, mass divided by molar mass. Then what is the molar mass? You can use periodic table. Cr molar mass is 51.996. You can use 52. So 52 Cr times 2, Cr2, right? And oxygen is 16 times 3. We convert mass into mole. Then we need to use this balanced equation. Every 1 more Cr2, need 2 more aluminum. Right, so 2 more aluminum in top because we want this more of aluminum. So forget here is more of aluminum, but here is the quantity we have is gram. It's mass, not more. So we need to convert more back to mass. According to that chart, from more to back to mass, more multiplied by molar mass, right? Use periodic table again. Aluminum molar mass is 26, yeah, 26.98 gram more. So use your calculator 55 divided by 152 multiply by 2 multiply by 26.98. This give you number is 19.53. This is the amount of aluminum needed, and the amount we have is 16 grams. So the amount needed is greater than the amount that we have. What does this mean? Nobody know? Do you know what does it mean?
16 is the excess.
No, the 16 is the excess. This is aluminum not enough. We need 19.53. But we only have 16 gram aluminum, right? So the amount we have is not enough, right? So aluminum is a limiting reagent. This right? Because we need 19.5 gram, but we have only 16 gram. Of course, aluminum is not enough. Then it is limiting reagent. Can you understand this idea? Because this is critical to George, which is your answer. Okay. Now, since aluminum is a limited reagent, then we must use aluminum calculate the reactive yield. No choice now. You cannot use excess reagent to calculate the reactive yield. Okay. So aluminum is a limited reagent, then you must use aluminum to calculate the reactive yield. Again, mass always convert to more. Mass divided by molar mass. Now use balance equation. Every 2 more aluminum produce 2 more chromium. Chromium is what we want, so it must be in top. Okay. So up to here, we get more of chromium. The reactive yield is mass, not more. So according to that chart, from more to mass is more multiplied by molar mass. The molar mass for chromium, use periodic table again, is 52 gram more. So use calculator 16 divided by 26.98, multiply by 2 divided by 2, then multiply by 52. This gives you 30.84 gram. So this is theoretically if 16 gram of aluminum reacted, then you should expect 30.84 gram chromium will be produced. So this we call theoretical yield. Then we don't have enough space. Let me write here, okay? Then percent yield. Percent yield is actual yield divided by theoretical yield times 100%, right? So actual yield, I always tell you, actual yield is you run the experiment, collect the product. You cannot do any calculation like here. 24.3 of chromium is actually produced. That is actual yield. So 24.3 gram. Theoretical yield we just calculated 30.48, not 48, 84. 78.8%. You okay with this? Now, many of you get lost for this one. I wish in the test you can solve this type of problem.